Welcome back as we continue Section 2 with the classification of matter, talking about the different kinds of matter, not in terms of the phases, but in terms of the different ways we can classify matter, in terms of purity and impurity. So all matter is a mixture of subatomic particles to make atoms. So protons, neutrons, and electrons make atoms. And then we put atoms together to make different kinds of substances. What we're talking about here is the different ways we can put atoms together to make different kinds of substances. And the first way we break down that classification is pure or mixture. Pure substances are either elements or compounds. Elements are the purest of the pure. You only have one kind of atom inside of an element. They cannot be broken down, chemically or physically, into simpler substances. The elements we're talking about here are the elements of the periodic table. No matter what you do, you cannot break them down, chemically or physically, into simpler substances. Compounds are combinations of two or more elements. So they are slightly less pure. They have more than one kind of atom inside of them. So you can break compounds down chemically. However, they cannot be broken down physically. So pure substances can never be broken down physically. Some pure substances can be broken down chemically, and those are compounds. Now, and something of importance to note, compounds, the different elements that make them up, always appear in a very specific ratio. And that ratio cannot be altered for that compound. For example, water is always a 2-to-1 ratio of hydrogen to oxygen. Any other ratio, and it's not water. That ratio cannot be changed. It is invariant. A very different kind of compound would be glucose, a very simple sugar, C6H12O6. That always contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Any other combination of atoms, and it is not glucose. Compounds always have those particular ratios. You can get different ratios, but those would be different compounds. Now here we have mixtures. Mixtures contain 2 or more pure substances. So mixtures don't have a fixed composition. You can have perfect infinite variation within limits. Okay? So, for example, salt water. You can go from 0% salt, pure water, to the saturation limit, when you cannot have any more salt dissolved in the water. But you can have any combination in between 0 salt and saturated with salt. Okay, and you would still have a mixture of salt and water. That's how you can distinguish between a mixture. No, that's one way, I should say, to distinguish between a mixture and a compound. With mixtures, you can have variation on the ratio. The other thing to note is that mixtures can be separated physically. Now, that physical separation might be more or less difficult. Like, it's easy to pick the tomatoes out of your salad. It's a lot more difficult to get the salt out of salt water. Either way, it's still a physical separation, because what we're dealing with there is physical properties, and we're not changing substances into different substances. We'll talk about that more when we get to chemical versus physical properties. But the point of a mixture is that you have the substance of salt, the chemical compound NaCl, mixed with the substance of water, the chemical compound H2O. And when you separate them, physically, you'll still have salt, NaCl, and water, H2O. Just as there are 2 kinds of pure substances, there are also 2 kinds of mixtures. There's the homogeneous mixture and the heterogeneous mixture. For a homogeneous mixture, there's only one phase of matter present in the mixture. So the mixture has uniform properties throughout. You look at it, you only see one phase. Okay, so salt water, NaCl mixed with H2O, there's only the one liquid phase in there. You look at one part of the water and a different part of the water, you won't see any sort of boundary. There's not salt here and water there, it's just a uniform mixture of salt and water. Not only that, but the properties of the mixture are the same throughout the mixture. You won't find a different sort of salt water over here, and another sort of salt water over here, and another. No, it should be uniform. Now, a homogeneous mixture is also known as a solution, because one substance has been dissolved in the other. We're going to be talking about solutions a heck of a lot later on, particularly when we get to chapters 10 and 11. Now, a heterogeneous mixture is probably what came to mind when I first mentioned mixtures. A heterogeneous mixture has two or more phases present. You can see boundaries between the different parts of the mixture. Okay, so a handful of sand is a heterogeneous mixture. A salad is a heterogeneous mixture. Ice water is a heterogeneous mixture. There's boundaries between the ice and the liquid water. There's boundaries between the lettuce and the tomatoes. There's boundaries between the different grains of sand. So, a heterogeneous mixture is no longer uniform. There are easily distinguished differences between different parts of the mixture. There is this rather simple flowchart that you can use to think about the classification of matter and the different ways we can talk about matter, pure and mixture, and different kinds of each. So, matter generally. That is the broadest classification for matter. Just matter. Something that has mass, takes up space. And then you look at the stuff, okay, this matter, and you ask, can it be separated physically? Okay. So, on the left we have the purest stuff, on the right we have the different kinds of mixtures. So, let's say, no, it cannot be separated physically. That means we're looking at pure matter. So the question we ask then is, can this matter be broken down chemically? Can it be separated into simpler substances through some chemical process? If the answer is no, then we're looking at an element, purest of the pure. If the answer is yes, then we're looking at a compound. Coming over to the right, if it can be separated physically, then we're looking at some kind of mixture. And we ask, how many phases are present? Does it have multiple phases? If there's only one, then it's a solution. If there's multiple phases, then it's a heterogeneous mixture. So that is matter, the classification, pure, impure, element, compound, solution, heterogeneous mixture. All right, see you next time.